Hi everyone, welcome to Chemstorming again. As you can see in today's video, I'm going to discuss about stoichiometry. So don't worry if you don't know much about stoichiometry, I'm going to start from the scratch. So what you can do is, you can just try out these questions, calculate the molecular masses of HNO3, H2SO4, AgNO3, list out the atomic masses of zinc, vanadium, manganese and iron. You can refer to the periodic table for these examples or atomic masses. And then finally, find out 3 examples wherein you have elements having isotopes and just mention those isotopes along with their masses, along with their isotopic masses. Alright, thanks so much for watching this video. So what are we going to cover in this video? What's the meaning of stoichiometry? That's the first thing I'm going to tell you. Definition of stoichiometry. Example to simplify the term. I'm going to show you an example. And then I'm going to tell you about 4 types of stoichiometric problems that we generally encounter. So let's start with the meaning of stoichiometry. This is actually a combination of 2 Greek words. The first one is Stoicheion, which means elements, and the second one is Metron, which means measure. So when we actually measure the mass or the moles of the elements, that's called stoichiometry. Now let's look at the definition to understand it in a better way. Stoichiometry means representing the exact mass or moles of the reactants which are required to react with each other without any wastage, and also finding out the exact mass or moles of the product which will be formed after the reaction. So here you can look at the 2 terms, exact mass and moles, and wastage. So we are trying to find out what exactly will be the number of moles of the reactants which should react, and after the reaction gets over, there should not be any wastage of any of the reactants. And using the stoichiometry properly, we can also find out the exact mass and moles, number of moles of the product which are going to form after the reaction gets over. So this is what exactly we calculate using stoichiometry. Now how to represent stoichiometry? Stoichiometry is represented by a balanced equation. So when you have a reaction, the first thing you're going to do is balance the equation, because in the balanced equation, the coefficients represent the exact number of moles. So what are these coefficients? Coefficients are those numbers that you write just before the reactants or the products to balance the equation. There are some numbers that we write to balance the equations. Those are called coefficients, and those are the exact number of moles which are getting formed in case of products and reacting in case of reactants. Now I am going to show you a dummy example to make it more clear. Let's consider a reaction 2A plus B gives us 3C. Now as you can see, there are already numbers written with this reaction, so the reaction is balanced. The first thing that we notice is the reaction is balanced, and the second thing we should look at is the molar ratio. This is the moles of the reactant A, and the moles of reactant B would be 1 because nothing is written next to it, and the number of moles of C would be 3. So the molar ratio is going to be like this. This is the first thing we should write while attempting to solve any stoichiometric problem. Now if I ask you what's the molar ratio of A and B, so molar ratio of A and B is going to be 2:1. Similarly, molar ratio of B and C can also be written as 1:3, and molar ratio of A and C can be written as 2:3. So now if A is given and we have to calculate C, then also we can do. If B is given and we have to calculate C, that also can be done. If A is given and we have to calculate B, that can also be done using these three different molar ratios, which is in fact the part of the main molar ratio which we have written it. Now, according to the definition, we are always talking about the exact number of moles. Why do we talk about exact number? Because suppose in any reaction you have 2 moles of A and 3 moles of B. So what is going to happen, that these 2 moles of A is going to react with only 1 mole of B, leaving out 2 moles of B. Now these 2 moles of B are wasted. So we don't want this wastage to happen. That's why we always talk about the exact number of moles, which is stoichiometry. Alright, let's move on to the next thing that we have to discuss. There are 4 different types of stoichiometric problems which we are going to discuss in subsequent videos. So what are the 4 types? First one is mole-mole relationship. Mole-mole relationship in which we have to relate the moles of the reactants with the moles of the product. This is the easiest one. You can do it in a single step. Then the second one is mole mass. So you will have to relate the moles of the reactants with the mass of the products. So here you have to actually convert the moles of the products into mass and mention the answer in terms of mass. Then the third one is mass-mole relationship, in which mass of the reactants will be given and you have to relate it to the moles of the product. And the last one is mass-mass, where you have to relate the mass of the reactants to the mass of the products. I am going to discuss all these 4 types in my subsequent videos, step by step, with a lot of examples. So just don't worry that I'm not discussing it right now. So let's summarize today's video. What have we learned today? We covered the meaning of stoichiometry and its definition as well. 2 Greek terms, Stoicheion is elements, Metron is measure. So we are measuring the exact moles and mass of the elements in a chemical reaction. Then I have shown you a dummy example to simplify the meaning of stoichiometry and what exactly we are going to work out. And then we also discussed that a balanced equation represents the stoichiometry of the chemical reaction, and that's the most important thing in any stoichiometry calculation. And also there are 4 types of stoichiometry problems: mole-mole, then mass-mole, mole-mass and mass-mass. And I'm going to cover all these in my subsequent videos. So just stay tuned to my channel. I hope all of you have enjoyed this video. If you have liked it, then please don't forget to click on thumbs up. Thank you for watching.